In this video, I'll be showing you how to find the equation of a tangent line on any graph. So, in order to find the equation of a tangent line, the easiest way to do that is using point slope form. So, y minus y null is equal to mx minus x null. And x null and y null are corresponding points on your line. So, if you had some line, there must be some point on it, right? That's what a line is. And you can pick any point off of this entire line and then use that for your x null and y null values inside of this function. And then m is the slope of your tangent line. So what is the slope of a tangent line? Well, that already gives you the hint. The slope of a tangent line is the derivative of your function. So in this case, we have a function x squared plus 3x minus 5. And we're trying to find the tangent line at x equals 2. So how do we do that? Well, first things first, I'm going to draw kind of an approximation of this parabola of a function. And we want to find the tangent line maybe somewhere along here, right? This is kind of what the tangent line looks like. Well, in order to find x null and y null, we need to pick a point on the tangent line. How would you find any point on the tangent line? You can't find this point. You can't find this endpoint. Right? Which point will you pick? Well, you will pick the point where the tangent line intersects with the graph. That is the definition of a tangent line, right? The tangent line intersects the graph at one singular point along the curve. So, if that point is on your curve, then you can use your function of the curve in order to solve for the y value of that point. So, if we plug in 2 here, for x equals 2, so let's say this is at 2. Then we get x squared, 2 squared, which is 4, plus 3 times 2, which is 6, minus 5. And then you'll get a y value of 5. So that means that this point right here, where the tangent line intersects with the graph, is at 2, 5. So x null, y null values are already 2, 5 in this case. So we solve for that. All we need to do last is find the slope. Well, the slope is simply just the derivative of your, let's keep this picture, that is useful, simply just the derivative of your function at that point. So the derivative of f of x is 2x plus 3. That's just using power rule. So if we plug in 2 into the derivative of your function, then you get 4 plus 3, which is equal to 7. Therefore, the derivative of your function at x equals 2 is 7. And 7 is the slope of your tangent line. So in order to find the equation of your tangent line, you write y minus y null. Y null in this case is any y value on a graph, equals the slope of your tangent line, which is the derivative of your function at x equals 2, times x minus x null, which is just 2 in this case. So, using point slope form, it kind of already tells you the steps of what you need to take in order to find your equation of your tangent line. So this guy right here is kind of like a formula sheet in some sense. Let's go ahead and find the equation of the tangent line for this function at x equals 3. So first off, we need to find a point on the graph, x null and y null. So a point on the tangent line is just the point that intersects with your graph. So all we need to do is plug in 4, 3 into your function. So 3 plus 1 is equal to the square root of 4, which is equal to 2. So that means your y value for your function is 2. So a point on your graph, a point on your tangent line is 2, 3. Okay, let's keep going. Now that we have x null, y null, we need to find the slope of the tangent line, which is a derivative of your function. The derivative of your function using power rule is, well, technically your function. Let's write down function of f of x is equal to x plus 1 to the power of 1/2. Right, and in order to find this with a derivative using power rule, you get 1 over 2 square root of x plus 1. Now that we have the function for our derivative, we can just plug in the x value. So plugging in the x value gives you the derivative at that x value, which is exactly what you want for the tangent line. So when we plug in for 3 here, you get 1 over 2 square root of 4, which is equal to 1 over 4. So 1 over 4 is equal to m in this case. Therefore, we can write our point slope form now. Y minus y null, our found value of y is, okay, I wrote this point wrong. Our figured out value of y is 2, right? That's the equation of, that's the value of your function at x equals 3, 2. Your slope is 1/4, and your x null value is 3. And this is your equation for your tangent line at x equals 3 for the square root of x plus 1. So let's go ahead and find the equation of the tangent line using your function 1 over x at x equals 1. So first things first, we need to find x null and y null. X null is already given by your given x value. So your function value is 1 over 1, as we replaced 1 with x with 1. And that just gives us 1. Therefore, your y null value is also 1. As your function value is equal to 1 when x is equal to 1. All right, let's go ahead and find the slope. Well, the slope is the derivative of your tangent line. And we can rewrite the function so that we can use power rule. So 1 over x is equal to x to the power of negative 1. Therefore, if we want to find the derivative of x, we can just bring down the 1 and subtract the exponent by 1. So we get negative x to the power of negative 2, which is equal to 1 over x squared, negative 1 over x squared. And we want to find the derivative at x equals 1 to find the slope of your tangent line. So we just plug in 1. Oops, I need to put 1 here. So negative 1 over 1 squared, which is equal to negative 1. Therefore, your slope is negative 1. So if we write down point slope form, y minus y null is just 1, is equal to m, which is negative 1, times x minus x null, and x null is just 1. So the equation for your tangent line is y minus 1 is equal to negative x minus 1 for the function 1 over x at x equals 1. So if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.